Welcome to iLectureOnline. In this video, we're going to attack the catenary problem in a more systematic fashion. There's actually 9 variables associated with this particular problem. Of course, the catenary is what we call the hanging cable problem, and it's somewhat difficult to figure out how to solve any particular problem you may encounter. The reason for that is because it will give you only a few of the unknowns. Now, what are those 9 variables we're dealing with? Well, we have y, x, h, s, and c. We also have w, which is the weight per unit length, and we have the tension at the lowest point in the cable and the maximum tension typically at the highest point in the cable, and then we have the angle that we have relative to the horizontal where the cable is attached to the attach point there. So those are 9 variables, and typically they only give you 2 or 3. For example, they may only give you s and x, they may give you y and x, they may give you h and x, and in each case you're going to solve the problem in a different fashion. Also, they're going to need to give you the weight per unit length if they're expecting you to find the tension at various locations in the cable. So how do you solve the problem? Well, to help us along, we have all the equations necessary right here in a box. You may want to commit those to memory, although that's quite a task if you're trying to do that, but it helps. And notice here that there's 5 variables that kind of give you the geographic or the picture of a hanging cable. The distance from the lowest point to the highest point in the horizontal direction is called x. The distance from the reference point where you reference C and the highest point where the cable is attached is called y. This here is called the sag, the vertical difference between the highest point and the lowest point on the cable. That's called the sag. C is an artificial variable, which is the distance from the lowest point to some reference point, and that reference point can go up and down. That's not actually the ground or anything like that. It's simply some sort of reference point that allows us to find the other variables. And then we have S, which is the arc length, or simply the distance from the lowest point to the highest point along the cable. It's only half the length of the cable if the 2 attached points are at the same height. Now, how do we solve the problem? Well, let's say that you're given the length of the cable and you're given this horizontal distance. This would be half the span of the cable, and this would be half the length of the cable. Well, first of all, we use this relationship. S over C equals the hyperbolic sine of x over c. Since s and x are given, you can then find c through a process called the iteration. And we've given you some examples of that, and we'll show you a few more examples. Once you determine c, now we can use these 2 equations right here, the relationship between y, s, and c, and the relationship between h, y, and c, h being the sag. That then allows you to find the other 2 variables, and now you know all 5, c, h, s, x, and y. If y and x are given, instead of using the hyperbolic sine, you're going to use a hyperbolic cosine, because that relates y and x instead of s and x. And since y and x are given, that's the perfect equation. Again, using the method of iteration, you'll find c, and then using the same 2 equations as before, maybe arranged slightly differently, you can then get all 5 of the variables. What if h and x are given? Well, then you start again with the hyperbolic cosine, but instead of using this format of it, you're going to first take y, which you don't know, and replace it by h plus c, because that's what we have from this equation right here. Y is equal to h plus c. So replace y with h plus c. Then you divide both sides of the equation by c, and you end up with h over c plus 1 equals the hyperbolic cosine of x over c. Then again, through a process of iteration, you'll find c, and then once you have c, you use the same 2 equations to find the other 2 variables, and now you know all 5. If they're expecting you to also find the tension in the cable, they're also going to have to give you the weight per unit length. If they don't give you that, you cannot find the tension in the cable at various points in the cable. And finally, they can also give you h and s, which is not one of the 3 examples right here, and that one you have to solve a little bit differently. So in that case, we're going to have another video specifically showing you how to solve for the problem if they give you h and s. So you're beginning to see that in order to solve the catenary in a fluent fashion, you're going to have to recognize which of the variables are given and then follow the appropriate steps to get the other three variables. And in conjunction with knowing W, the weight per unit length, you can find the tensions, and then you can also find the angle that the cable makes with the attach point using this equation right there. And that's how it's done.